Okay, I'm putting together my flat disc alternator with the bucking permanent magnets. Here's the, see that? That is where the bucking happens, right in the middle there. It's north against north, while the magnets are north, south, north, south, north, south, and there's 8 of them. It's got a bearing on the bottom. It fits right in there. This plate's adjustable up and down, loosening these nuts. And this bottom black plate is stationary, and that's where the bearing goes in. So I'll put this in here. That's in there, and now I'll put in the next stator plate that goes on top. Hold on. Okay, I put in the second stator plate. 7 coils on top, 7 coils on bottom. Total of 14 coils. I checked the ohms on each one, and they're all about like 4 ohms or 3.5, somewhere around there. It's Litz wire, wound in sewing machine bobbins like Romero UK. This is what I had, a Romero UK replication. I just took these coils out of that. Ferrite cores. And okay, so now I'll put on the top plate, which will center this, stabilize it. Okay, I put the top plate in with the 7 more coils. You can move it around a little bit and get it exactly lined up with the bottom coils. And this plate is also adjustable up and down by loosening these nuts here as well as the bottom one, so you can adjust the air gap very easily, very finitely. And that's going to be important if this is going to work right as planned, because the permanent magnets shoved together, bucking right there in the middle, glued in place. That field in the middle there stretches higher than the fields from the flat surfaces. So it seems like what you want to aim for is for that field, the bucking field, and not the flat ones here so much, but that bucking field to be cutting right through where the ferrite is. And that's how I made it to be. See, there's that, it goes right centered on the ferrite, that gap between. So if you have it so that bucking field is what induces in the ferrite and the coil, then there should be no lens or minimal lens. This is what I'm planning on. So okay, now I'm going to put in the top plate. Okay, now I'm going to put in the top plate right here. This has where the roller skate bearing is going to fit in there. I'll just put it on for now and put the bearing in after this. So it's going to fit on there. This is going to be completely stationary, and the black one on the bottom stationary. So the distance between the top bearing and the bottom bearing is always going to be the same, and you don't want too much pressure on the bearing. You want just a little bit of free play so the bearing, so the rotor will spin smooth and easy, while this plate and this plate with the coils on it, they are adjustable up and down. So this is pretty good design, as it's really easy to adjust the air gap between the magnets and the coils above and below. Okay, I got it together. There's the air gap right there. And not too bad. The shaft kind of goes up exactly 90 degrees to the base. And it spins nicely. Makes a little butta as it goes past. Not much though. It's nice. Remember, we have 8 magnets versus 7 coil positions, although it was originally 9 coil positions, but I took out 2. So I'm gonna spin this by hand and just put a meter and see how many volts 1 coil can make. Maybe. Okay, hold on. Okay, I got leads hooked up to this coil up here. Just 1 coil. And I'm gonna do the lower one. Okay, this is at about that many ohms, this lower one. And we're gonna hook this up to 600 volts. Let's do 60 volts AC. Okay. Now, let's spin it. Maybe I'll get half a volt. Almost half a volt, come on. There we go, half a volt. Now let's put it over here in 20 amps and put it in AC 20 amps. And now let's see what we get. Probably not much. Not bad. Wow, that's actually quite a bit. Does that say 140 milliamps? Yes. That's pretty good. Let's try this one over here. This coil up here on top. Also about 150, 140 milliamps. Let's put this over in voltage. 60 volts AC. Makes a little more volts. So that's not bad at all. Okay, and I don't know what's rattling. Okay, it's looking pretty good. 14 coils, hand spin. Not very fast, just hand spin like this. And we have about a half a volt, so let's say we could have 14 coils would have about 7 or 8 volts AC and 150 milliamps. But let's do that at 1800 RPM spun by a rotaverter. It's going to be something probably pretty good. Main thing is what is lens law going to do when you load all the coils. Okay, there we go. This is called a permanent, let's see, bucking permanent magnet flat disc alternator. Okay, thanks for watching.